Welcome guys, Sizosake here, Sizosake Academy, and this is the global classroom. We are instructed to calculate the value of cot x if sine x is equal to 8/13. Now, cot x would need us to have cos x over a sine of x. We don't have the values of cos x, we only have the values of sine x. Sine x is equal to 8/13. So we need to also find the values of cos x. Now, this is what we must do first. We draw up our right-angled triangle and put our x here, or our theta here. It should be x because we're looking for x, not for theta, but it's okay. And we are told that sine x is 8/13. We know that sine x is equal to opposite over the hypotenuse. So by giving us 8/13, they've told us that our opposite side is 8 and our hypotenuse is 13. But we don't have the adjacent. Let me put this here. We don't have the adjacent, which is what they want us to find. This is our y value, which is the opposite. This is our our IR value, which is the hypotenuse. Y value is 8, R value is 13. We don't have x. So we cannot come with cos x until we found x. So we come back here, we come back to what we call Pythagoras theorem. Now I'll write it down. I've said it before but didn't write it in other videos. Here I will write. Pythagoras says the square, hope you'll see my writing, the square of the hypotenuse of a right angle triangle is the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the other two sides. Of the other two sides or of the other sides, it's up to you, but it says the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the other two sides. The square of the hypotenuse, this is the hypotenuse, the square of this hypotenuse when it's squared, of a hypotenuse of a right angle triangle, it's got to be a right angle triangle. It can't be an isosceles triangle. It cannot be, an equilateral triangle. It cannot be an isosceles triangle or any other triangle, but it has to be of a right angle triangle. The square of the hypotenuse of a right angle triangle is equal to the sum of the squares, we add, is equal to the sum of the squares of the other two sides. We've got other two sides, which is x squared plus a y squared. This is what Pythagoras is saying. Now here we're looking for x. We've got r squared, we've got y squared, we need to find x squared. So here r squared, because we're looking for, so what I'll do, transpose y to the side will become minus y squared plus its positive r squared is equal to x squared. This is the same as x squared is equal to r squared minus y squared. R squared is positive, y squared is negative. I just left it there. So this is what Pythagoras is saying, but Pythagoras goes up to here. Here we are manipulating the equation because this is the value we want. We're not looking for r, we're not looking for y, we are looking for x squared, and this is it. I'll wipe off this so that I can carry on. I thought I should write it like this time because I've said it too much without writing it. Oh, shouldn't have wiped that. Just to clear my board so that it's clean and bright, you can see clearly. So x is equal to unknown, we're looking for x, therefore we have x squared is equal to r squared minus y squared. We need to find the value of x using its 13 all squared minus 8 all squared. 169 minus 8 squared is it 64, and here we got 9 minus 4 and 6 and 6 is 105. Am I correct? 105. Let me quickly check my calculator. My calculator. 105. I'm correct. 105. But remember, we are not looking for x squared, we are looking for x. Therefore, here we've got x squared is equal to 105. We put a square root this side, a square root this side. We've got x is equal to, and what is a root of 105? 105, it's 10.247. It's 10.2469507, but usually leave it in 3 decimal places, which is 10.24. This is 7 because this is 9. It gives this one 1. It's 10.247. This is our x value. Now that we've found the x value, we use it here. X is equal to, it's no longer unknown, now it's 10.247. Right. We have now found our x value using Pythagoras. Now we have to find this value we are looking for here. I'm going to wipe this off because I've placed this value here, and now I know you know how we got this value using this. That's my eraser has gone dirty. My eraser has gone dirty. Yo. Just to wipe it off quickly. Just want you to see how I operate. Yeah, it's good for you to see how I operate. It's drying up, it's drying up. Let's give it a few seconds. Right, so we need cos, because we need to find cot x. We've already found these values. We know cot x will be equal to the cos of x over a sine of x. Now cos x, this is x, mind you, cos x is adjacent over the hypotenuse, which is 10.247 divided by 13. We divide this by a sine of x, which is 8 over 13, because we are given, but we've got it here as well. So we've got 10.247 divided by 13 divided by 8 over a 13, and this is 10.247 over 13 multiplied by 13 over 8. This cancels and this cancels. We've got 10.247 all over 8. And let's see what we are getting. 10.247. We divide this by 8, it gives us 1.28. 1.281. This is our answer. This is our answer, guys. 10.247 divided by 8 gives us 1.281. This is what we have. Substitute the values, replace, and and we get here. This is it, guys. Thank you so much for watching.